I'll wait for 1 more minute. Students are still joining. In the meantime, anyone has any questions for me?
So the quiz due today is based on the homework problems, right?
It's based on whatever we have done in the class for chapter 1,
Okay.
all the topics. So there will not be anything outside that from chapter 1. Any other questions? All right. Yes. I don't know exactly, but it will be, I think, less than 30. It's not, yeah, because quizzes are timed 70 minutes. So there are not that many questions. Any other question? And each quiz will have different amount of questions depending upon how many important topics are covered in that particular chapter. And that's why I split it chapter 1 homework into 3 different homework, so that instead of having a long 80 or 90 questions assignment, you have 3 different assignment, and you can understand the concept of each assignment, each topic, while using the same assignment for that particular topic. And your quiz will be on 1.2, 1.3, 1.4. All right. So somebody posted 20 questions. So in quiz 1, there are 20 questions. Thank you. Thank you, John. All right. Good morning, everyone. Happy Wednesday. And I think last chat there were some questions about when we are moving to on campus, how is this class going to function? And as we discussed and mentioned in the very first classes or first week of semester as canvas, this online synchronous Zoom meeting is only for first 4 weeks, and this is the third week. So next week we will still continue this Zoom meetings, but once we move to campus, on-campus classes, we will not have these Zoom meetings. We will have the regular class meetings on campus, and I think you can check in the syllabus. Our classes will be on Sullivan Science Building. I don't remember the name on top of my head, but you can check. And definitely, we will send an announcement before we will be moving to on-campus classes. But as of now, February 15th will be our first day when we will be having on-campus classes. And again, I have been repeating this many times that this class is assigned as face-to-face classes. So if you are looking for an online option, completely online, this class is not the class for you. And as of now, I have instructions only to move the class for 4 weeks. I don't know what information I'll receive next week. But so far, the classes will move to campus on February 15th. And our first test will be conducted on campus. So again, if you need to decide, please decide it fast, because once you take the test or you miss the test, if you're not coming to the campus, then that grade will not be counted towards your actual grade. And each test is what, 15% of your actual class grade. And if you want to discuss anything regarding the moving the class, this is what I have. But again, if you want to meet during my office hours or some other time and want to discuss, please do it as soon as possible, because the drop rate is already passed, which was January 25th. But again, there is a withdrawal date. If you want to wait until then or see, like, it's your decision, but try to do it as early as possible. Excuse me. So last class we started chapter 2, but let me start all over again. This chapter 2, chapter 1 and chapter 2, your test will cover these 2 chapters. So as you see in your syllabus that February 15th we are conducting the review session for the test. So that means technically we will finish or we will complete this chapter by next Friday. And at any time, if you have any questions regarding any concept, feel free to stop me during the class or meet me or Miss Minion after office hours. You have Math Help Center. I have been telling you, Miss Minion is also telling you that there are two tutors, one including Miss Minion and one Mr. Philip. They are there. Their office hours or their tutoring hours are also uploaded on Canvas under Math Help Center tutoring hours. Good advantage of that. If you have any questions, check with them, go over with them. But again, at any point, if you feel that you need more help, extra help, just let me know. And give me 1 second, so I have to. And if you are writing messages on chat, Miss Minion is checking, but some of the answers she might not know. So if you have something that is not clear, just let me know because I'm not reading your chat messages. All right, now it's now it's not connected. Give me 1 second. All right, it's connecting. I don't know. It was connected before. What happened? Can you guys see my screen? No.
It's loading or says it's loading.
Okay. Because my side I can see, but I don't know what's going on. We took the time. Sorry about that. Oh, I don't know what the issue is. Our class time is anyway 50 minutes, 5 minutes already passed. So I'll try one more time, and if it does not work, then I will use my board. So until it's connecting, let me just quickly go over what we did in the last class. So we talk about the relationship, looking at the data, and how looking at the data and how the data or what kind of relation that data has. So when we talk about the relation cannot be possible with just knowing one thing. So the relationship will be possible only when we have two things. So when we talk about relationship at the data or when to here, I think it's connecting. All right. Can you still see my screen? You cannot see my screen. You cannot see my screen.
We can see it, but you're on mute.
Can you see now? Can
Yes.
you hear me now? Okay, perfect. Oh, so sorry about all this mess. So let me just quickly start. So looking at the data relationship, so when we are saying relationship, the relationship cannot be possible until we have something where we can find the relationship. So we in chapter first we talk about univariate, and uni means basically one and variate variable. So we talk about one variable. So when we are looking at the relationship, we are talking about bivariate data set. So when we are talking about bivariate data set, we are talking about two variables, and then we are looking at the relationship between those two variables. So when we say bivariate, so we are talking about two variables. One variable is called your explanatory variable, and the other one is called your response variable. And what is explanatory and what is response? So explanatory variable causes the changes in your other variable. So if I'm saying that explanatory variable is that variable that explains or the cause in your other variable. And response variable is the variable that measures the outcome of a study. So explanatory variable, let's say if I'm talking about two variables, X and Y. So if I'm taking X on here and Y here, so as I move X, so as I increase or decrease X, what are the changes in Y? So when we are measuring the outcomes, then we are talking about Y. So Y is your response variable. So in this particular case, and then X is your explanatory variable. So again, explanatory variable is a variable that may change or that may explain or cause changes in your other variable. So when we say explanatory or response variable, when we have two variables, we can use those two variables to see if there is a relationship going on or not. So when we talk about the relationship, the first thing we draw some kind of graph to see if there is a relationship going on or not. So when we talk about variables, we talk about two kinds of variable. One is your categorical variable, and one is your numerical variable or quantitative variable. So when we are talking about numerical variable, and we have two numerical data set, and we want to see if there is a relationship between this going on or not, the very first thing what we do is we make a scatter plot. And what is a scatter plot? A scatter plot, when you're making a relationship, when you're looking at the relationship between two, especially numerical variable, I'll come to this also. When you make a plot that has points that are scattered around, so let's say I have this. So this is my X, this is my Y. I cannot make this dot until I know what my X is, what my Y is. If my X is 1 and Y is 5, then this point will tell 1, 5. Same thing, this one 3, 2, or 4, 3, something like that. So let's say if I have 3 here, 2 here, 1. So each dot on the scatter plot represents both x and y. And once you make a scatter plot gives us an idea what kind of relationship we are looking for. This scatter plot is depicting. So when we look at the relationship, either linear or non-linear. Variables, you look for four things. First is form, second is direction, and third is strength, and the fourth one is again outlier. Very similar like how we did in chapter 1 when we look at the overall shape of a histogram or a stem plot. We look at four things, shape. And now when we are looking at the overall relationship between quantitative variables using a scatter plot, we will look for these things. What is the form? What is the direction? Or how strong these points are close to that form? And if there are outliers in the data set, that is making a form a little bit different. So when we are talking about form is either linear or non-linear. Again, linear means when you see a form that is making a form of a line. So let's see if I use a scatter plot. I use my data set and I see something like this. So if I see something like this, and let me make another one. Something like this. So this is my first scatter plot. This is my second scatter plot. When I look at my scatter plot 1 and 2, the very first thing I'll see, what is the form of this scatter plot? What kind of form? What form I see here? Can I make a line using those dots on the scatter plot? Can I make something else other than a line? Is there a pattern or something? So when I look at this, I can see that if I can look at this, I can see there is a linear pattern here. What about this one? When I see that, and if I connect those dots, I can see there is a curvature going on. So when we see a linear pattern, we say that the form is linear. To look for linear or non-linear, which is form. So once you know that your form is linear, now you need to look what direction that linear pattern is. What direction? Is it going upward or downward, or is it positive or negative? And how do we see positive and negative? So once I know that there is a linear pattern going on, something like this. So when I see this one, when I move my x from 1 to 2, 2 to 3, 3 to 4, 3 or 4 to 5, what happened to my y? Is y also moving up? So if I'm moving x to from 0 to 1, 1 to 2, 2 to 3, what happened? Let me take this point or this point or this. So what happened when I move x? When I increase x, my value of y also increases. So if I move x from 1 to 2, my y also moved to 2. So when I increase x, my y also increases. Or I can look it other way. From 5 to 4, if I move x from 5 to 4, what happened to my y? Y also goes down from 5 to 4. And not necessarily that the number should be exactly the same. The whole idea is if your x going up, y also going up. If x going down, y also going down. If they are going in the same direction, we say that it is positive or upward direction. And you can say that it's going in the upward direction. So when it's positive or upward, that means both x and y are following or going in the same direction. If one going up, other going up. If one going down, other also going down. Now let's look at this one. Excuse me. This. So here I can see that when I increase my x, my y decreases. And let's see this. So as you keep the value of x, the value of y going down. Or let's go back. If we are moving from here to here, my y is moving from here to here. You go down, but your value of y increases. From here to here, value increases. So when you go x in the downward direction, y is going up. And when you go x forward, your y is going downward. So when they are in the opposite directions, when one increases, other decreases, other increasing, the previous one decreases, then this is negative direction or downward. So this is our second step, direction. We need to check first form. Once you know it's linear, then look for what kind of linearity, positive or negative. And then the third step is to check the strength and the strength of this linear pattern. And again, when we are saying strength of this linear pattern, then we will see how closely these points are to make a linear pattern. So here, if I have a linear pattern, and again, we will talk about how to draw a line in the next topic when we will talk about least square regression. But when I see a linear pattern here and here, the points are very close to the line if I make a line here, but here the points are a little bit farther. So this is more strong comparatively to this. So the strength of this one is more stronger than this one. And again, we will look at different scatter plot, and then we will try to see which one has more strength, which one has less, or how closely these points are to the linear pattern. Again, when we look at the scatter plot, it's very subjective because for me, if that might be strong, but for you, your stronger one will be this one, or for somebody, even this is strong. So we use something to measure the strength of a linear pattern, and that is called your correlation coefficient. And we use with this as well as this symbol. So some places you see R, some places you see rho. So this is correlation coefficient, and it is a useful tool to measure the strength of a linear pattern. Now, what this correlation means? And when we are saying correlation, before correlation, let me use the word association. So when we say two variables are associated, association means related, right? So when we are saying two variables, x and y are associated, that means they are related. That relationship can be anything. That can be linear or nonlinear. So when we are saying association, two variables are associated. We don't know if they are linearly associated or non-linearly, but they have some relationship going on. But when we say correlation between x and y, if we are saying correlation between x and y, that means they are linearly associated. So two variables are linearly associated, so we can say that they have correlated. So correlation is nothing, it is another word for linear association. So instead of writing linear association, we are using the word correlation. So correlation means there is a linear relationship. Then we should not doubt x and y are correlated. Are they linearly related? Yes, because correlation means linear association. But if I say x and y are associated, I cannot say there is a correlation going on because they are associated. That association can be linear or nonlinear. And then we will check what is the value of R or rho. And then we will see if there is a correlation going on. And if there is a correlation, what is the strength of that correlation? And this R or rho is a number between positive one and negative one. So this R can stay in this bound. So correlation coefficient can be between -1 and +1. When we are saying -1 and +1, so let's make a number line. So it is in this range. So when we are saying, and why we are using -1, because we are talking about linear relationship, and when we are using the equation of the line, we use it as 1 or -1. So if it is positive linear relation, then we are saying R is 1, right? And if it is linear negative, or then we are saying that R is -1. So that's the max we can have. So -1 and +1. When R is +1 or R is -1, we have perfect correlation, perfect linear relationship. So that, because that is the max they can have. Now the question is, when I'm using R equals 1 or R equals -1, which one is more stronger? Is R equals 1 more stronger or R equals -1 more stronger? What do you guys think? Any?
Is it the same?
It's the same, because we are talking about positive direction and negative direction. So this negative sign is telling me just the direction. It's not making my value negative. It's just telling that there is a positive or the negative relationship or negative correlation going on, and positive perfect at R equals 1, and here also perfect, but it's in the negative direction. So positive and negative sign just tells you the direction. It does not tell you that this is weak or this is strong. Now, when we are looking for -1 and +1, that's the max we can have. Once we have this, it's perfect. But what about if we have something other than -1 and +1? So it can be -0.81 or -0.21 or 0.99 or anything, right? So when we are talking about correlation, R, the strength, it is a number between -1 and +1. So it is in the decimals. If we have this perfect 1 and +1, then definitely we have either positive or negative correlation. Other than that, it's in decimals. And when we are talking about R equals 0, because we have that 0 also comes between -1 and 1, that means there is no correlation. So that means no correlation. If I'm moving from here to here, anything closer to 0, weak correlation. Anything closer to 1, strong correlation, because 1 is the max we can have. Same thing, anything close to 0 in the negative direction, weaker correlation. And then it's getting moderately strong, stronger, strongest, and that's the max. Same thing here. So any number or the correlation value R closer to 0 is weak, and away from 0, closer to 1 and -1 is strong, and 1 and -1, it's perfect. So this is about correlation, and correlation is nothing. It is a linear relationship between two variables. If there is a correlation, there is association. Correlation, then there is an association. And what kind of association? Linear association. But if there is an association, we cannot say that there may or may not. So there may or may not, there may be a correlation, there may not be a correlation, depending upon what my R value is. If R value is between -1 and +1, yes, there is a correlation. And if it's not, then there is no correlation. So let me move back to the slide and see if I missed something. So right now we are talking about the relationship between two numerical variables. So scatter plot is the best way, or you can say scatter plot is the first step to see if there is a relationship between two numerical variables. We can also use scatter plot for categorical variables. But that scatter plot will not tell us any relationship. You can use categorical variable to make a scatter plot, but that scatter plot will not tell us any relationship. And let's say if you see the map of, let's say, word map, in word map, you see different colors and different symbols. So blue color represent water, and green the land. So you can see all those categorical variables there. Some places you can see different symbols, and each symbol you have a key, and that key tells you that this represent what does that represent, what does that represent. So you can use scatter plot to make categorical variable. The only thing is it will not tell us any relationship. And again, if we need to find the relationship between two categorical variables, we use two-way tables. And we will talk about this in the end. It's the last topic in this chapter. So two-way tables help us to see there is a relationship between two categorical or qualitative variables is going on or not. So scatter plot, first step to see if there is a relationship between two numerical variables exist or not. If it is it linear or non-linear? If so, what's the direction? And if I know the direction is positive and negative, what is the strength? And then if there are outliers in the data set or not. If there are outliers, again, outliers, when we say that, that is like something outside the overall pattern. Let's say I see a clear linear pattern, but I see one outlier here. So that will give me the linear pattern, but it will change or it will shift my line. So if, let's say, if I'm doing this with the outer with this outlier, it might move to this because it is on this direction, or if there is an outlier, it might move this, and that will change my value of R. So the fourth step that we discuss is outlier, that is lying outside the overall pattern. Some outliers are influential, that change the value of R. Some outliers are not influential, they will not affect anything. So again, influential outliers are those outliers that affect your correlation. And if they are not affecting, then they are not influential. Questions up till this point? So the definitions are given to you here. A response variable measures an outcome of a study. An explanatory variable explains or causes changes in the response variable. One more thing, when we talk about correlation, we know there is a linear relationship going on. But I don't know which one is my explanatory variable, which one is my response variable. I can still see what my relationship is. So if I'm using this, X and Y, to make a scatter plot, but I don't know which one is my explanatory and which one is my response. By the way, explanatory variables are also called as independent variables, and response variables are called as dependent variables. And why they are dependent? They need something, and that is they need independent variable, and then they are dependent on independent variables. So when we are talking about explanatory and response variable, and I need to use a scatter plot to do C, X, and Y, and I need to do these points, but I don't know which one is my explanatory and which one is my response. Let's say if I'm taking height and weight, and how my height changes with the weight, or the weight changes with the height. So let's say if I do not know which one is my explanatory, which one is my response, I can still make a scatter plot. It will still tell me if there is a linear relationship or not. It will still give me the value of R. So it will not get affected if we do not know, or if we cannot discriminate between explanatory and response variable. If we cannot see the difference, which one is explanatory, which one is response, I can still make a scatter plot. I can still see the relationship. I can still find the value of R. But when I'm trying to find, or I'm trying to predict the value of response variable, so that means I need to see how much is the response when X changes to this. When my height changes to this, what happened to my weight, or what happened to the when the age is increasing, is my height increasing, decreasing? So I need to know what I am looking for or what I am predicting. So that will be your response variable. So next topic, we are going to talk about prediction or least square regression line. In that, you need to know what your explanatory variable and what your response variable. So when we are talking about correlation, if you know there is a distinction between X and Y or explanatory and response, well, good. If you do not know, you can still work with that. But next step, when you want to predict something, you need to know what you are predicting. So what you are predicting, that is your Y. And then that is your dependent variable because you are predicting that using something else. And then other is your independent variable. So this is what we learn in chapter 1, individuals or cases, labels, categorical values, and now we added extra point, explanatory or response. If appropriate, classify each variable as explanatory or response. And if you do not know, then yes, you can still make a scatter plot. The scatter plot shows the relationship between two quantitative variables, and make sure you remember that because there are questions either in your homework or quiz somewhere where they ask you scatter plot is the best way to measure the relationship between two numerical variables, two categorical variables, both numerical and categorical, or none. So you need to know that scatter plot we use for categorical, but categorical variables, we cannot find the relationship using this scatter plot. And again, the quantitative variables should be measured on the same individual, so two values on one variable. The value of one variable appear on x-axis and other on y-axis, and each case corresponding to 1 point in this graph. So this is one individual information xy. Decide which variable should go on each axis. If you know which is explanatory, independent, put that on X. If you do not know, just use whichever on X, whichever on Y, and see if there is a linear relationship. And here is an example. And again, you can make your scatter plot using your calculator. You can enter your data in list 1, L1 and L2, and then you can see a scatter plot. You can use any technology. On Launchpad, there are a lot of data sets are provided. Under resources, you can use Crunchit or any other software, Excel. Just use that data set and hit scatter plot, and it will provide you a scatter plot. Excuse me. So this 14 and 60. So then you are looking for one as X. So your price is as X. So this is on 14 and the other one is on 60, and then this. So somewhere. So this particular point, same thing, you can see all these. This is one individual, and then you have value of X and Y. Now, interpreting scatter plot, we talk about that we need form, direction, strength, and we also look at the outlier. So it says that it is very similar like how we did in chapter 1. We talk about shape, center, spread, and outliers to look at the pattern. And same thing here, we are also doing any graph of the data, look for the overall pattern. And for striking deviation of that pattern, you can describe the overall pattern of a scatter plot using these. And again, outliers, that is lying something outside your overall pattern of the relationship. Positive association or negative association, again, we are talking about the direction. If it's positively associated or negatively associated, if one going up, other going up, or if one going down, other going down, we are talking about positive linear relationship. And if one going up, other going down, or one going down, other going up, we are talking about negatively linear association. Interpreting a scatter plot, again, now we are using all 3 things or 4 things that we learned. We are talking about form, direction, strength, and if there are outliers in your data set. And if I look at this pattern, and This is something that is lying outside my overall pattern, and this I can consider that as an outlier. And if I ignore this, my line will be, I can see there is a linear pattern. Since there is an outlier, it will change, or it will shift my line little bit towards the direction of the outlier. So again, there is a moderately weak, because when I see the linear pattern, the points are not very closely related. Points are not very close to the linear pattern. Direction is positive. Definitely, I can see either this or this or this. One going up, other is also going up, and it is a linear form. And yes, there are outliers. There is one outlier in the data set. So that's how you read a scatter plot, or you can say interpreting your scatter plot using that four uh, steps: form, direction, strength, and outlier. Adding categorical variable, as we just discussed, you can add categorical variable using different symbols as well as different colors. If you're using blue or green, and then make sure that you make a key on the side and tell what does this represent and what this represent, so that we can see which area is covered with that category and which is covered with the other category. But again, it will not tell us any relationship between two categorical variables. So to add categorical variable, using a different plot color or symbol for each category. Form, we all talked about that. So there is a linear form or non-linear form. Non-linear form is anything other than the form of a line. So I can see here there is a curvature. The points are very close to make this pattern, but this pattern is not linear, right? So they are very, very close. It's good strength. Strength is, it is very strong relationship, but not linear relationship. So note that the curvature in the relationship between x and y, but it is of a non-linear form. Correlation coefficient R. You can see this also. And in your homework assignment, there are questions based on your using the data set and see the relationship using Minitab. So I will explain that part in the next class, because if you see those, where are those results coming from? So you can use Minitab also. And then properties of R. Measuring linear association. So scatter plot displays the strength, direction, and form of the relationship between two quantitative variables. Linear relationships are important because straight line is a simple pattern that is quite common. And when we look at the scatter plot, again, reading the scatter plot for the strength is very subjective, because when I look at that scatter plot, that might be looking very strong to me to make a linear pattern, but that might not be the case with you. So we use correlation coefficient, or R, to measure the strength, so that that number will be same for everyone, and then we can take the decision on the basis of that instead of just reading the scatter plot, just looking at the scatter plot and take the decision. So our eyes are not always good judge of how strong a relationship is. So we use a numerical measure to supplement our scatter plot and help us interpret strength of the linear relationship. So correlation measures the strength of the linear relationship, and there is a formula how to calculate this correlation. And this formula looks very complicated as of now, but believe me, you understand it, what is this formula talking about, and then you can use calculator or any software to do your problems. So let me just talk about what we learned before in chapter 1. We use this formula to calculate variance, right? And then we did the square root of variance to find the standard deviation. Everybody good with how did we calculate this part? Just this part, we did xi minus x bar. So that means I calculated the mean first and subtracted that mean from each observation, and then add everything, do the sum of that, and then did the square. I'm kind of doing the same thing. Here I'm talking about only x because I had only one data set. Now I'm talking about two variables on each individual. So I'm talking about bivariate, not univariate. So I have X and Y. I have both. So I am going to do the same thing what I did here for X, same thing I'm going to do here for Y. So I'm going to look for X bar and Y bar. And what else I need to do to calculate the correlation? Once I do this, then I need to find the standard deviation of both Sx and Sy. Once I have these things, once I have the mean of X, mean of Y, standard deviation of X, and standard deviation of Y, I will apply these values in the formula. And the formula is nothing different. If you look at this, this is xi minus x bar. So subtract the mean of this, and you have done this part already when we calculated standard deviation. Then divide with the standard deviation of x, and again the sum of all. Same thing you do here, and divide with the standard deviation of y. Multiply everything, and then divide with n minus 1 observations. So however, whatever your n observation is, subtract that n minus 1. And again, this is how you use formula. How to use the calculator to find the correlation. If you go on your stat 108 notes, and again, I'm not explaining now, but if you go on 2A, you can find this information on the bottom of your 2A notes, where it says that how to calculate your correlation using your TI-83 or 84 calculator, or how to make a scatter plot. So you can check that information, and you have information on your launchpad also, how to calculate correlation using your scatter plot and using your TI-83 or 84 calculator. And again, if nothing makes sense, just Google how to use TI-83 or 84 to calculate correlation, and you get that information. So take a look at that. And again, if you have any question, let us know. Okay, measuring association. So I have 2 more minutes, so let me just complete this topic. So measuring linear association, we use correlation. Correlation is a number between -1 and 1. R is greater than 0, indicates positive association. So that means 0, 1, -1. R is greater than 0, that means you are going in this direction. Greater than 0, positive, and less than 0, negative. Value of R near 0 indicates a very weak linear relationship. The strength of the linear relationship increases as R moves away from 0 to -1 or +1. You cannot have the value of R as both positive or -1. You can have only one, because you have either the positive linear or the negative linear direction. You cannot have both. So if R is going from here to positive direction, it's getting stronger as it is moving from to 1, and it's getting weaker as it's moving close to 0 in either direction. The extreme value or the maximum value of R is -1 and 1 occur only in the case of perfect linear relationship. And when I look at these graph, I can see if there's a linear association or correlation going on. If there is going on, if going on in which direction. And here I can see that there is a linear, and there is a linear pattern in most of them, but this value of R tells me that there is no correlation. There is, but not very strong, very weak, because it's close to 0, negative because it's going in this direction. Here, 0.5. So there is correlation, but it's not very strong. And what kind of correlation? Positive. Here it's negative, and we see that the points are making a clear linear pattern. So points are very close. So it's very, very close to 1, and same thing with the other. Last topic. Correlation makes no distinction between explanatory and response variable. It has no units and does not change when the unit of measurement of X or Y or both changes. So if you change the unit of X or Y, correlation does not change. Positive R indicate positive, negative indicate this, and it's all a number between -1 and 1. I guess it's time, so I'll stop here, but if you have any questions, let us know. Thank you, everyone, and I'll see you guys on Friday. Have a wonderful rest of your day.
Thank you.
You have a good weekend.
Thank you.